Thanks to the host guys. Ace as well. Thank you guys. I'm up. Tonight, Eldridge, Spectrinster, Hayes, Prime 7. Hi guys, Zerful as well. Get you missed the post. I believe so, yeah. Can you hear me now? Yeah, I didn't have the mic pulled out, so it was behind my monitor. Oh, there we go. It's all running now. Yeah, hi guys. So I've been thinking the past couple of days about a lot of the projects that I've got on the go. There's a couple that I'm not going to do on the stream, but I'm going to start kind of rotating stuff in a little bit. Hey, Sinlo. Welcome to the stream. Did everyone get those points? Yeah. Okay, cool. 25. Yeah. Are we breaking up? No. So I've got another project coming up, which is I'll let you know more about it when I start it. But I wanted to test out an idea for it that I had. And what I'm going to do is I'm going to start rotating. Tell Ismore. Thanks for the resub, Andy. 11 months. Wow, that's crazy. Yeah, I'm realizing that I get the most stuff done when I'm doing it on stream. So I'm going to start rotating Tuesday and Thursday with some other projects as well. So there's one project coming up which is kind of exciting. I'm looking forward to it. Thank you for the resub again, Amok. 13 months. Wow. Very impressive. Yeah, so I just wanted for this new project, I'm going to do it completely on stream. It's a port of an existing game, and it's being done for somebody. I'll let you know when we actually start it. But tonight I wanted to test out some particles, because one of the things the game has is some particle systems in it. So I wanted to see if I could do that at a decent speed. So I've been thinking about that a lot, about how to do it. Oh, I'm missing everything. Thank you for the follow, TH Lorenz, and thank you for the gift sub, Amok, for Tiny Small 69. I'm live for Thalamus. No. I'll let you know when it's coming. It's a port of an existing game. But it's I think it's well suited to the C64. I just need to get an idea of kind of how much of the original kind of graphical style I can keep. So so that's what we're going to do tonight. We're going to do some particle tests. So I'm going to start just by creating a blank, well, not a blank, but a charpad file that gives me something to work with. So essentially, what I want to do is I want to use the last quarter of this. I'm going to turn the music down ever so slightly. It's just a little bit loud. And I'll start the races as well. Tomb Raider for IDOS, Fall Guys 64. No. You'll know soon enough. I'll probably be starting it next week or something. So, but I'm going to start rotating things in. So we're gonna do Parasol Stars on Saturdays once the main game's done, which I'm excited to pick up again. I've got some ideas about how to improve on what I've already done. We've got the Game Boy game on Tuesday. We're going to start doing a Mega 65 game in November. That will be part of the rotation, but basically Tuesday and Thursday are just going to interchange. So it will kind of alternate between 2 or 3 different projects. But it seems to be the only way I can get things done at the moment is to do them on stream, because every other time I'm just asleep. So okay, so basically I'm going to create a very, very simple pattern in here. Just be something like this. It really doesn't matter. Just because I want something to put on the screen. I'm going to actually paste that everywhere. Just have to do it all the way down like that. There we go. So one of the things that I'm trying to do is make this work with character graphics, not bitmap graphics, which would be the normal way of doing this. So I might clear them without edit, clear, control, delete. I think 2, 3, 4. So that gives me 64 characters. Okay, and then I'm just going to create a very, very simple kind of screen on here, just to leave the top one blank. Actually, it doesn't really matter for this. So the idea I've got is to use character graphics to do this, but to do it in a way that is efficient and quick, and allows me to have maybe 100 particles on the screen at any one time. And by particle, I just mean a single pixel dot. It's all going to be in high res mode, so there's no multicolor to worry about. There's no color to be placed in the background. Bit of Last Ninja. I do like this tune. This will do as a test, I guess. I mean, all I'm really doing here is testing that my placement works. He's not drinking wine. He would have let it slip by 11:30. No, you'll know soon enough. You'll know soon enough. Leak it on Patreon. Oh my god! Did you use all your bits already? Why did you use them all on? I only just gave you 10,000. Did you bet them all on a race straight away? Hey, Bojan Learned, I miss you. Welcome to the stream. You didn't get any. I wonder why. Yeah, it doesn't seem to give points properly. Maybe I should do this in a different way. I'll give you 10,000 now directly. There we go. No, I have to spell add points right, I guess. There you go. I give up. He was late, sir. Oh, damn it! I just given him some now. I don't think it works properly, that add points thing. I might have to do my own version of it. Okay, so I just want something really simple like this. It should be fine. Let's just put it in my Dissect stuff. It's really not about the quality of these graphics. I'm just going to call it test. That's fine. And I'm only interested in 2 things from here. So I'm interested in the map because I just want something to show on the screen. So I'm going to call that map.bin. And I'm also interested in the character set. Okay, right. Let's call this start.asm. So even though this is probably going to be the basis of a commercial release, I'm happy to share this bit of code, assuming it works. I mean, it might not even work. So my idea is quite simple, really. I'm basically reserving 32 or 64 characters at the end. However many I reserve it is entirely up to kind of the performance of this. And then for every particle that gets placed on the screen, it's going to, first of all, it's going to look at the screen currently and see if it's a blank space or not. If it's a blank space, then it's going to replace that blank space with the next character in the list. So it's, every time it does this, it's going to start here. When it replaces a character, it's going to replace it with the next one in the list and so on. It's just going to keep going. If it gets to the end here, it's just going to stop drawing particles. And then on the next frame, it will come back to here again, but it will start from wherever it left off in the particle list. So if you use more than 64 characters, it will alternate between two sets, which should create a little bit of flickering, but it should allow us to have way more particles on the screen. The trick is going to be in how I store the particle data and how to implement the kind of route, the clear and the draw routines as quickly as possible. Let's start by just setting everything up. So do my usual, turn off the interrupts here. I'm going to set 35. So this is turning off the kernel and the basic and cancelling the interrupt so it doesn't break when I clear the interrupt flag here. Okay, and then we'll have a loop here, which we're just going to jump to. So we need to import the graphic asset. So I think for this test, it's perfectly fine to leave the screen where it is at 0400. Although we do have the map to import, so maybe I'll import it somewhere different. Actually, no. I think if I import it up here, it should import correctly. So if I do, let's try it. .bin, because it's gonna import the map into 0400. Then this is gonna create a basic setup at 0801. And then we'll put the character set down here at 0200. Actually, let's do it right at the end. Let's do it at 3800. So the reason I want to do this is because I want to be able to have lots of particles on the screen, but I want to also have a really powerful sprite multiplexer as well. So I want probably 24 to 32 sprites on the screen at one time. And so in order to have both of those things, I need to make this part pretty efficient, which I think I can do. We'll see. So, so let's import the character set and then set up the VIP registers. Binary chars.grid. And then I need to set up the VIP register to point to the right place, and I can never remember which one it is. Let's go and have a quick look. I think it's D018. I need to check. Yeah, it is D018. So, and it's the last 3 bytes. So, well, last 4 bytes, 111. And the first bit will stay the same. So this will be 0001 1110. There we go. Right, so hopefully this should just display our screen now. Open file map.bin. Oh, really? Do I have to do that, maybe? Oh, if I've saved this in the wrong place on it. Where on earth have I just saved that? Oh, I've saved it into the C64 game, which is not a good place to save it. Let's just delete it from now. Thankfully, I didn't overwrite this one. Not that it would have mattered. I could could have got it back from the GitHub, so that's fine. So yeah, there we go. Okay, so it's weirdly it's jumped back into here, and it's kind of done the right thing. What am I doing wrong here? Jump loop. I don't think it's set. I don't think it's set things properly. So I'm going to move the screen up to 300-400. Which means I need to change the pointer to be 1101. So, there we go. Right, okay. I'm going to set the background to black and fill the foreground with white. Actually, it doesn't matter about the foreground for me. It's not the important thing here. But let's set the background black. I do prefer a black border for tests like this. Okay, so the idea is I need to be able to store a particle on the screen anywhere. Can I have another? Have you spent it already? Oh my god. What did you spend it? Did you go all in? Oh my god. You went all in on mayhem, and who won? Bub wins. No, you can't. But you'll. I'll do another raffle after the break. Oh god. Oops. What's going on here? I've got some weird thread window open in my chat for some reason. I don't know what that's about. Never seen that before. Okay. Give me 500k and I'll give you 1 million basic prize. Yeah. Oh my god. Bribery. Okay, so I want to I want to store the positions of the particles. Now, the first problem we're going to have here, and the thing that's going to slow us down, is if you store a single pixel position here, then you've got 320 positions this way. So you need to store that in at least 2 bytes to get that 9th bit. So I was thinking about this, and I was thinking, well, wouldn't it be better instead of storing the X and Y like that, to store them? Let me show you. Let me create some data space down here. So I'm going to put it at 4,000, and I'm going to call this particles. So what I was thinking was, instead of having the data stored something like this. So let's imagine this is one particle. You might have an X position, which might be something like this, and then a Y position. That uses 3 bytes, and the problem with this is we would have to convert this into screen space in order to get the screen position. So I was thinking, well, if you are updating the position of a particle, you're going to add a value to this, to the X, or you're going to add a value to the Y. So I was thinking it would make more sense if you just had a screen position. So if you just had 4 bytes instead, so you'd have something like, well, our screen is at 3,400. So if we did somewhere kind of, let's say 2036. So this is our screen position in terms of characters. And then this bit here would be define X and Y. So in the same way we have scroll register that goes from 0 to 7. Yeah, I don't know why give points doesn't work. I thought that was a stream elements command, but I'm not sure. Let me just check. Maybe I need to turn it on. Hang on. Yeah, so the idea is instead of storing the coordinates as pixel values, horizontal, vertical, is to actually store them. No, that is stream elements. There we go. Let me just connect to this one sec. It's to store them as screen positions and then find values. I could just split. Yeah, I could indeed just split this. So it would still be in one byte. But the reason I'm going to keep it separate is for speed. I don't want to have to. I don't want to have to shift those values at all. I'm trying to reduce the amount of values. Okay, give me one sec. Let me just turn this chat command on. Give points. Give points. Yeah, it wasn't turned on. There you go. It's on now, so you should be able to do it now. I don't know why it's not enabled by defaults, but it's not. Should be working now though. So yeah, Zenderik's right. You could essentially combine these two. So instead of find x and y like that, you could store it like this, with this one being x and this one being y. But the reason I'm not doing that, is, as you'll see in a minute, is for speed. So there's one other thing you can do for speed here, and that is instead of storing x as a value from 0 to 7, like so, is you store it as a power of 2. So 0 would actually be 0, 1, 2 would be 2, 3 would be 4, and so on. So I'm going to store it as a power of 2, and the y doesn't matter. The y can stay 0 to 7. Now the reason this is important is because if we want to turn a byte on, so say this is the row of bits on the screen that we want to turn on, and we want to turn this one on here. So this is bit 5. Okay, so in the old method it would be 0, 5 here, and the first thing we'd have to do is we'd have to look up a value in a table to work out which bit to turn on here. So we'd probably have a table of powers of 2. I look a value up and then turn that bit on here. But by storing the values as power 2 here, you can skip that step. And the interesting thing is in order to move something to the left or right, all you need to do is use logical shift right and arithmetic shift left. It's actually quicker than just adding values here or incrementing them. And the carry flag will let me know if it's leaked over. And if it leaks over, then I need to add 1 or subtract 1 from this value here. So actually, it should work out to be pretty quick, I think. So that's my plan anyway. And then there will be some additional bytes here, which are basically just going to be things like particle type, direction, speed, that sort of thing. So for now, they're just going to stay blank, but this is essentially the format that we're going to have. We're going to have 4 bytes which define the position that we're going to show on screen, and then 4 blank bytes which we're going to use for any additional information we need for these. So for instance, one of the things that will be updated in the particles is once we go to draw a particle and it works out which character number we want to put it in, one of these values will become the character number. So when it goes back to draw it, we just have to did Hayes go all in again? Oh my god. It's funny. Okay, so let's have a look at how this is going to work then. So for now, I'm just gonna keep one particle here, and then what I'm going to do is I'm going to create a draw particles function, and a clear particles function, and right here I'm going to create max particles. Here actually, constant max particles. That's going to be, for now, let's do 64. We'll see as we go along if we can implement that or not. And for now, I'm just going to fill the rest of the particles up with blank. So we're just going to deal with one particle for now. So the way I'm going to handle this is if the byte here is 0, then the particle is inactive. So that's how we're going to clear it. I'm trying to make sure all the comparisons that we do are compared to 0 or compare if something is positive or negative. So the idea being that we don't have to use the comparison operands. We can just do the branch if equal, branch if not equal, that sort of thing. Okay, so this is just going to fill our particle area with this. Okay, so to draw particles, let's just call a draw particles here and just make sure that this is working first. Okay, so this is going to be our draw particle loop, and this is going to be our clear particle loop. So the other thing that's important with the particles is to have an index which points to which particle number we're at. And the reason for that is because if we get to the end of our character ROM, our free character space in here, then we're going to stop drawing particles, and we need to remember where the index is so that we can return to that point at a later date. So the way this is going to work is pretty simple. We're not going to actually store a particle index, but what we are going to do is we're going to set up the particles. So we're going to have an init particles here. I'm going to create some 0-page stuff here as well. So the first thing we're going to have in here is the particle fetch pointer, I guess we'd call it. I'll just call it particle fetch. And this is just going to be a pointer to where the current particle data is. And so the initialization here is going to basically fill that in. So we're going to grab the lower byte of particles, store that at particle fetch 0, a byte of particles, store that at particle fetch 1. I've got to say as well, I have no idea if this is going to work. I'm just having a guess here, and just thinking about this today. I think this is a system that might work quite well, but we shall see. Okay, so init particles is basically going to set up that address here. So we need some other information here as well. So we've got maximum particles. We're going to have particle char count, I think we'll put in here, which is also going to be 64 at the moment. This could change. And particle size, which is 8. So particle size is just the number of bytes that we're using per thing. I'm keeping it at 8 for now because I think that's probably going to be how many extra bits of information I need, because I'm going to need charon value, character kind of number, if you like, for here, a dx and a dy, so a delta x and a delta y, and then maybe a particle type as well, which will define whether the particle has gravity or whatever. That will just be so that when we're processing the particles, we can jump to different routines, so they don't all have to follow the same update code. Okay, so we're initializing the particles, and we're just about to draw the particles. Let's get my drinks on the go. I'm drinking cream soda tonight. It's like ice cream in a can. It's amazing. catch it up with chat. Okay. So let's draw the part. Let's just draw the current particle that's being displayed, and we can look at how we can optimize that little section of routine. So, that was the sheep mates when we all know what an idle sheep is. Lady sheep is called. I think I'm gonna slip drinking that. Yeah, it's really nice. I like bar. They're good. They make iron brew as well. So and they've got their head screwed up. They know how to make addictive drinks. Okay, so to draw a particle, we're going to need two things. We're going to need to know exactly where the next character, the next character is going to be in ROM. So I'm going to keep that in here as well. So let's call it next particle char here. And this will just be a byte. And this is just going to start at 0. So I'm just going to set that up with 0 in here. So in the init particles. So this is basically just hey CB Mix, welcome to the stream, dude. Oops. Okay. So whenever we go to draw the particles, what we need to do is the first thing we need to do is we need to grab the address, the screen address for it. So we're going to do that by grabbing the first 2 bytes of the particle. So the way I'm going to do this is we're going to have a register here, which we're going to use to grab values. The first thing we're going to do is we're going to grab particle fetch, y. Going to have another thing in here. We're going to have screen fetch. Do you need to set the... Oops, I can't read that properly. Hang on. Do you need to set the memory address to the start program? It's currently 0 page. No, because I'm using basic upstart here. It should create it. Let me just check that as well. I just need to make sure that that's correct. Yeah, okay. It should create two blocks. Oops. Although for some reason it's not there. Maybe I need to. Do I need to do that after? I can't remember. You see there, it's created the 0 page block, and then the basic upstart actually creates this block here, and also this block for the entry point here. So it does create these. This kind of block of code here creates the second. Some of the Kicks versions break that. Yeah, so I'm on 5.13, and I'm not going to update after the mess that Visual Studio Code had with CB Minx and Retro Steve as well. I'm just not going to update for now. I just followed your tarmac video, modified for 4x4, and it works a treat. Yeah, it's quite proud of that tarmac video actually. It works for arbitrary tile sizes, which is nice. It's a pretty useful piece of code. I'm sure I'm going to use it myself at some point. Probably on this project actually. I'll have to see. I'll have to see how it's going to work. Okay. So we're going to grab these values and we're going to store them at screen fetch plus 0. And then we're going to do the same again, but with an increment y, and so that's screen fetch 1. Now at this point, we know now if this is 0, then we can skip. So I'm going to put skip here, and I'm going to put branch if equal skip. So that will stop it will just set this value up and then it will stop. So already this is kind of using quite a lot of cycles, but when you consider the alternative, which is converting from kind of bitmap coordinates, if you like, to screen coordinates, this would be a lot bigger. So kick assembler updates break your entire code base. Yeah, well, it shouldn't be your code base, but I definitely noticed Visual Studio Code seems to have some issues with it, but we should maybe report those bugs actually to them. I'm sure they will fix them. Should make it open. That's what they should do. Thanks for the sub sender, Eric. Very much appreciated, dude. Welcome to the subs. Okay. So now we have the screen location. So at this point now we can start grabbing things from the screen. Now, unfortunately, hang on, do we need to do this right now? Yes, we do. Okay. We've already incremented y here to 1, so we do need to decrease it back again here. So what I'm going to do every time I mess with the y, I'm going to just write the values that it's incrementing or decrementing to here. Because unfortunately, we can only use y for this particular addressing mode. But now we have the screen fetch here. Okay, so this is going to tell us whether the value is 0 or not, which is what we want to know, because our map is using these values here, which are anything other than 0 and 0 for all the negative space. So the first thing we're going to do is we're going to do a check here. God damn it. We're going to do a branch if equal, and what we're going to do is we're going to set this to be, let's see. No, actually, we'll do branch if not equal. So if it's not equal to 0, we'll do non-zero here. We'll just put. So if it is equal to 0, that means what we can do is we can then take the next particle char here. Is it raining? Oh my god, it's... Oh, hang on, let me just shut my door so it doesn't get wet. That rain's been a long time coming. That's going to be nice. It's going to cool it down a little bit. I was shocked. I didn't recognize the noise. It's like, what is that? Okay, so where was I? Yeah, so if it is 0 at this point, then we can grab the value that's in next particle char, and we can store that probably in this location here. So let's make a note. So the first one here is going to be char value. I'm actually going to store that in X register. I'm going to store it later, but we're just going to grab it for now from here. If it's non-zero, then what we need to do now is we need to check if the value is more than what is essentially going to be 256 minus minus, what's it called? Particle char count. If it's less than that, we go to skip again, because if it's not 0, what's that? No. If it's not 0, which is this one here, then the only other one that can have something drawn to it is one of these down here. And so by doing this check here, we're checking, is it one of the other non characters, non kind of dynamic characters? And so that's what that skip is doing there. So there needs to be a jump here, so I'm just going to put that there for now to remember. Otherwise, then what we need to do is we need to grab that value. The carry bit will be set now, so we should just be able to subtract particle char count and transfer that to the X register. And now the X register is going to contain the character number. When I say character number, I mean for the dynamic character. So this is going to actually be 0, not 192. Even though it's 192 in the character, it's going to be 0 all the way up to 63. So here we need to increment next particle char. And here is char selected. Jump. Char selected. Right, okay. Okay, so now we know which character number we need to draw to, and we know where on the screen that needs to be. So the next job then is to actually draw that value to the screen. So which we actually only need to do here. We don't need to do it here because it should already be drawn. So we'll do it here. So before we jump, we do basically the opposite here. We're going to add this value in here. And we're going to store that at screen fetch, y. We'll probably need a clear flag. Do we need a clear flag there? Let me think. I'm going to clear it anyway. We might be able to get rid of that. So the char at this point, let's put a note in here. At this point, char has been selected and drawn to the screen if necessary. And so now all we really need to do is we need to take these fine values and use them to draw into the character. So this is where the problem comes in. So all we have at the moment is this character number, the value that's in X. So X is going to be from X equals 0 to particle char count -1. But we need to convert that into memory addresses, which is not going to be so simple. So the way we're going to do this is we're going to use an unrolled loop to do this instead. So what I'm going to do here is I'm going to create a plot pixel. And the way this is going to work is we're going to take the value in X and we're going to use that to work out where to jump to in this routine here. So the easiest way to do this will be a jump table. And so that's how I'm going to make this work. So pixel jump table. This will be for var 0 is less than. Now this will be particle char count this time. And this will be a shitload of words basically. Actually, we can do this. We do this as bytes. We do high byte and low byte. This will be even more efficient. So we'll do like so. And then this plot pixel routine here is basically going to be a loop. I've got to remember how to do this now, because this is using kick assembler loop labels. Labels arguments, multi loops. Let's find it in the code somewhere. Loops, branching and looping. For directive. Oh god, I can't remember how to do this now. Okay, so let me just set the label up and then we'll try it. So we'll call this pixel loop. And it's basically going to be the same as this. But then here, what I'm going to do is I'm going to take, so we have a value. I am going to grab that value. It's going to be in the accumulator already. The Y register, I will change. No, I will use the X register to grab this value. So it's going to be something like this. Store accumulate something, comma X. Just going to put beef there for now, but it will change. RTS. That simple. Really quick kind of thing. Now, I may change this to something else, because this could just be a jump back to our point here. But for now, I'm just going to put RTS and then we'll work out. I think it probably will end up being a jump routine, but let's just try and get this this loop together first, because I can't remember how to do these labels. So can I run this at the moment? Is this runnable? If it's runnable, I just want to check something. I think it is runnable, even if it's not going to do anything. Okay, that's runnable. And you can see there, it's actually drawn something, which I think is the wrong character actually looking at. So let's run it in the debugger and have a quick look. So that should be a blank character. Yeah. Can't actually see what the value of that is. Hang on. What's it now? This one. Window. No, it doesn't. Still doesn't show me what that value is. Okay, I was hoping it might show me what the value is at that point. Fine, I'll go and find it in the memory map. So here's the memory map. There is one value. There is the other value. So it's actually put a value in, but it's the wrong value. So that's fine. We can go and fix that now. It's put 40 in, which is this value here. So it's grabbed the next particle value, which should be 0, next particle char, because we set it to 0 here. Oh, and it's added the particle char count. No, it should be 256 minus the particle char count. There we go. So now if I run this, we shouldn't see anything up here. It'd just be blank, and it's because it's actually drawn a blank character here, which is fine. So I just want to see if these loops work now. So hopefully what I can do is pixel loop I like that. And that would be lower. So that would be up. I think that's how it works. Let's see if that compiles. No, it doesn't. Okay. Unknown function or invalid number of arguments. Okay, let's get rid of the thing around it here. Actually, I don't really need pixel, but I can call it plot pixel. It's fine. I've got to remember how this works. I know you can do this. I just got to remember how the hell you do it. Loops. Branching labels. Where's labels? Sometimes finding the information is a little bit awkward in here. In the kick assembler manual. Labels. Accessing local labels. Here we go. No, that's not it. That's not it. Oh, it's in that lot somewhere, surely. Ah, okay. So this is I, and let's call this plot like that. There you go. That's better, right? Cool. So what you do is you have a label on the outside in front of the loop, and then you have a label inside the loop, and then you can refer to them like so. Cool. So this is now going to let us create a jump table for each potential address in memory. So the way we're going to do this is really, really simple. So we're going to take our memory address here. We're going to add 256 minus particle char count times 8 plus I times 8. And I'm going to put all these bits in brackets, even though I probably don't need to. So what's this doing? So this is, first of all, it's working out where the start of our characters are in memory with this bit. This is where the characters start in memory. This is where the dynamic characters start in memory. And this is where each of the individual characters begin. By adding I times 8, we get each one individual. So the next step here is, now we know what the character is selected. We have that in the X register. We can use this to grab pixel jump table, comma X, pixel jump table MSB, comma X. And if we put a jump instruction here with brackets, this is an indirect jump. This isn't used very often, but we're going to use it here. Itchy nose. And I'm going to call this jump return, because we are actually going to come back to this point. It's already feeling like a lot of code, but I'm hoping this is still going to be quite efficient. Start with jump self mod +1, jump self mod +2. So the only other thing we need to do now is we need to make sure this jumps back to jump return here. We need to make sure X has the correct value in it from this table here, so this value, and we need to make sure accumulator has this. So in order to do that, we're going to load Y with O2. It is currently at 0, so it's probably just quicker to do this. Yep, that's fine. Then we're going to load the accumulator with particle fetch, comma Y, which is going to give us this value. And then we need to put X in that value. So actually, let's go backwards. Let's start here, transfer that to the X register, decrease the Y. So that becomes 2. Okay, so if I run this now, I should see a single dot on the screen. If I don't, I see something flickering here. This is a bit odd. Okay. It is very odd, because it shouldn't be drawing multiple things. The loop the loop stops here, so why it's flickering, I don't know. Okay, let's put some breakpoints in and see what's happening. So I'm going to put a breakpoint here. I want to see what goes on. I'm going to go for a break in a minute anyway. Why is that not running now? Strange. I think I was pressing Control Shift. No, I do know you can do that. I mean, I remember you telling me that, but I prefer to do it the way that I'm doing it, also Coda, just because it doesn't look quite right to me. I'd rather use the +1 method like that. Does the jump table cross a page boundary? Possibly, yeah. Actually, no, it doesn't at the moment. Okay, let's see what's going on. So we should have at this point an accumulator, which is the value we want to plot, which is 2, 0. And Y X register should be the index, which is 0, 6. So this is the X. So the accumulator is the X position, basically, and the X register is the Y position. Sounds weird, but oh, also this doesn't need to be indirect, so that's the problem. I don't know why I'm doing indirect there. This would just be that. No need for this to be yeah, it just needs to be that. It doesn't need to be self-mod at all. So that's probably what the problem is there. There we go. We can see a pixel. Yeah. Yeah, didn't need to be indirect at all because we're using self-mod, so it doesn't need to be indirect. Would it not be better to jump to subroutine than indirect jump? Also, would it not be better to jump to subroutine than indirect jump? Then you could just RTS back. Normally, if you're trying to write something a bit more readable, yes. But in this case, we're trying to write very efficient code, and RTS is actually quite a heavy command. Jump to subroutine and RTS are quite heavy. I think they're like 6 cycles or something. So let's just have a look. So jump to subroutine is 6, and RTS is also 6. That's 12 cycles for that. Whereas jump is 3, I believe. Yeah, 3. So so we're using half the number of cycles to jump into this and then jump back, and we're trying to be very cycle efficient here, because that's going to be the most important thing. Okay, with that in place, what I want to do now, I'm going to take a quick break actually, but when I come back, what I'm going to do, I'm going to fill the particles right up with random values, and we're going to try and plot them all over the screen and see how long it takes to actually run that routine. And then once we know how long it takes, because we'll just call it every frame, we'll just call draw particles every frame here and use some border trickery to see it. Once we've done that, we can take a look at this routine and see if there's any way we can trim it down a little bit, and then we'll look at the clear routine, because the clear routine is obviously also quite important. I'm going to put the clear particles here, and I am actually going to do the a line here just to keep this on a bike, on a boundary here. I did not manage to draw a single pixel. So the data for the single pixel is a screen address that we need to draw out. So this is screen address 3620, an X value to the power of 2, and a Y value, which is normal. So this is instead of going from 0 to 7, we go up the powers of 2. So we go 1, 2, 4, 8, 16. So that means that if you just draw that value directly into that location, it will draw a pixel there. So one thing we do need to do actually is it's not, we don't need to store it like this. What we do need to do is we need to OR it with that value and then store it with that value. So it's actually a little bit more because when there's 2 pixels in the same row, they will then overlap. So that needs to be done for the plot. No, I'm not on a bitmap screen. So what it's doing is as soon as it knows the screen location, it grabs an empty character from the character set. So we're using these characters here. It grabs an empty character, plots that to the screen, and then uses that. And so we're gonna do this in a way that these dynamic characters are going to be drawn and removed from the screen. The idea being that 64 should be enough to cover most particles, but even if the particles go over 64, the routine is set up in a way that it will loop back around and just use the index where it's at, and hopefully it will allow us to have more than 64 characters worth of stuff over the screen with a bit of flickering between them. So it's kind of multiplexing between frames. All right, I'll be back in a few minutes, guys. I really need to run to the toilet, so be right back. So I'm back. Any big wins? It's kind of hard to see. Oh, there was a Dot Cosmos winning there, 25,000 for Mr. G. So nice. Okay. So at the moment, this is just drawing one particle. So I'm going to fill this up with some random values now. So so I'm going to create a variable here for the screen location, which is going to be 3800 plus random times, and this will need to be 4 as well, because it's going to give us a stupid value. 1,000, there we go. Which means this can now be the lower byte of screen address, upper byte of screen address. We'll keep these the same. Oh, got a weird alert there. Let's check that phone. And these values here. So this will be power, and this will be 2 to the power of random times 8. That floor as well. And this will just be 4 random times 8. So this is literally just to fill the screen with data, basically. So let's run that again. Hopefully we should see a random particle if it's not touching. Okay, it's crashed there for some reason. Let's keep that particle there, just make sure that's still working. Okay, so that one's working, but this one isn't for some reason. Okay, let's go and have a look in memory at those values and see what they are. Because it should be plotting a pixel there and it's not doing. Bubby's having a good run tonight, I guess. Let's do a raffle as well. So okay, so I want to go and check some values in memory. Is that not working? Why are my buttons working? There we go. So these look fine. 3A6 would be somewhere on screen. 2004 should be fine. Let's just turn off the background completely for now. Let's just do that and just do fill 1000,0. We'll add the background back in shortly, but hopefully we should see a single pixel on the screen, and we do not. What's it actually doing there then? That again. If he's trying to plot something. Oops. What is this tune? Oh, Delta. It's a big old tune, this. Oh my god, that's the worst joke in the world. I may have to just hire you, Acmafin, to just say jokes on command. Because the joke bot is not working out. Joke bot is just not funny. Okay, this is weird. It should be grabbing that value, and for some reason it seems to be failing and not showing that value. Oh, because I'm looking at charts, not screen. Ah, that's why. This should be 400. There we go. Okay. There we go. We've got a single dot on the screen. Okay, cool. So now we're going to try and make it plot all the dots. So we're going to do this here. We're going to have another value in here, which is going to be particle count. And what we're going to do, we're going to set this to the number of particles we want to draw each frame. And the maximum, for now, the maximum number is going to be the maximum number of particles. There's no reason to do anything different here. And we're going to start that here. So this is going to be the beginning of our loop. So we're going to load max particles here. And we're going to store that at particle count. And this is our loop here. So we're going to make like that. And then what we need to do here at the skip is first of all, we need to decrement the value in particle count. If that's equal to 0, then we go to end. Otherwise, what we need to do is we need to take the particle fetch value at the particle size, store that here. That's just going to make sure that it goes through every particle. So let's see how that works at the moment. Oh, okay. So we got a crash there. Get a crash there. Let's see. Think. Okay, should be fine. Yeah, we need an Acma bot, don't we? Light screen. Okay, why did that fail? Why did that fail? Let's try a few less particles. Let's do 8 and see what happens. Okay, we're definitely getting 8 particles there. Okay, max particles, maybe max particles -1. Maybe that's what I need to do. Sort of. I mean, we're getting this weird flashing thing here. Okay, so I want to look at this now in Debugger, because what I want to see is how is this actually drawing to the screen now? What characters are we seeing in what locations? So actually, we're not seeing as many this time. What's the reset command? I forgot what the reset is. Reload and start. Control L. There we go. No. Oh my god, it's just being strange. Okay, there we go. It seems like the code is locked up. It's oh no, it's stuck in this bit here, so that's correct. Okay, and if I reload, doesn't like me reloading it though. That's the weird thing. Oh, there we go. So I can reload like that. Okay, so this seems to be fine. And if we go and have a look at the characters in the character map, wherever they are, we can see all the pixels are here. You can see it's drawing them all slightly differently. Now, do we have any that are occupying the same square? That maybe is there. No. So that's the other thing I want to make sure that they can do is occupy the same square. So none of them do seem to be doing it at the moment. Oops. Move this around. I just have to zoom in and out all the time. I need to use this view a bit more often. I need to get used to it. Okay, let's just shorten the range of places that they can go to just 100 places. You should see a very different outlook then. It's just not running at all there. This extra thing here is a bit frustrating. I'm not sure why it's doing that. It doesn't seem to allow us to draw into the same spots, maybe. So let's have a look what's going on. So so when we draw, we fetch the next particle chart here. So actually, we do need to do a check here to see if we've reached the end or not, which we shouldn't do because the particle chart count is the same at the moment. So this is fine, but I'm going to put a to do here. Check end of particle charts. Yeah, I'm not sure why it's. This should be ORing the two values together. This should be the only place that it plots it. Okay. So let's run it in the debugger again. So a bit on a screen that I can deal with. I don't know why this extra character is appearing here. That's the one that's bugging me at the moment. It also looks like it's still running kernel routines. Because something is jumping to this location here, which is our IRQ vectors. I don't know why it's jumping there though. Well, it shouldn't be doing. But it might explain why that's appearing. Let's put some more stuff in here. Okay, so let's do all our checks in the bottom part of the border. So don't think that's going to make any difference, but yeah, it's still putting that there. But you can see now it looks like it's sharing the pixels over. No, see, occasionally it breaks like that. Why is it breaking? What am I doing wrong in here? Turning off those. Turning off those. I mean, we shouldn't even need to clear the interrupt. Let's just turn that off just to see if it is some other interrupt that's kicking in. No, something else is going on here. I do not know why. Maybe we're not jumping out of this routine. Maybe it's stuck in this routine for some reason. So let me put a breakpoint in here. Make sure we're actually getting out. Yeah, it does look like it's running the cursor, doesn't it? That's why I left the see, it is to do with this routine. It's never getting out of this routine. Okay, which means it's something to do with this here. This particle count is not going down all the way to 0 for some reason. So I'm going to put a breakpoint right here to make sure that this value does get decremented. So that is at 0.7. 0.7 is now 3. So that should go, and then it breaks. It gets to a certain point and then it breaks. Okay. Do you save the edges in there? There is no interrupt. That's the thing. There is 0 interrupt here. It's just getting to a certain point and break, and I think it's probably maybe to do with this. Although why, I don't know. It should be fine. Let me do nothing in this routine to see if it actually. Yeah, something weird is going on. Something weird is going on. Let's not do the jump here. Let's instead. If I just change that to a load of key there. Break here. Just want to see if I hit that break point. Okay. Okay, so it's hitting the break point. So it's something to do with the jump for some reason. It is not jumping to the correct place in here. So that is probably because, where are we getting that value from? So we're getting that value from the X here. So the X is maybe not in this range. So let's put a breakpoint here and see what X values are coming through. So I would expect these to be, we grab the screen value here. If it's non-zero, we jump to here. So if it is 0, then we're here. We load the next particle char value in from 0 page, which is fine. Then we increment it so the next one is ready, and we store that value in the screen. Otherwise, we need to grab the value. So it's non-zero, so we come to here. So we compare if it's less than our dynamic range value. If it is, we go to skip. Otherwise, we do this. So it must be this bit here, this particle chart count that's wrong. So I think if I just do a breakpoint here, I think that might work. You might see that the problem is. So the X is 0 at this point. 1, 2, 3. So this is correct. This is incremented. Thank you very much for the bit, Samuk. Oh, and I missed a follow from an hour ago. Erto Tuto, thank you for the follow, dude. So I'm just waiting for this value to be there we go. X is now at 85, which is incorrect. So this is the problem. So the question is, why is it 85? So it looks like that value is 85. We subtracted the pixel char count. Because we need to subtract this from it, that's why. Right, that should fix that issue. So the reason we weren't seeing pixels overlaying each other is because every time they overlaid each other, it would fail. So actually I need to put that back to a jump. And there we go. We can see pixels sharing the same space now, which is perfect. So in that case, what I'm going to do is I'm going to extend this to back to the entire screen, so it's 1,000. And I'm going to put here the particle draw routine. And we're going to just do some border increments here and decrements on the side. So now we can see how long it takes to actually draw these things. I like to indent it so we can see what we're actually testing here. Okay, so it's kind of screwed up, and I don't know why that's. Oh, I know why it's screwed up. So it's screwed up now because what's happened is when it's got to the end, this next particle char value here needs to be reset again. So this needs to be reset to 0. So this will actually be reset at the end of clear particles. So I'm going to put this into clear particles. Oops. Like so. And the other thing we need to do is also reset this value if it reaches a certain point. So if this value here reaches the end of the particle fetch space, then we need to reset it again. So the way we're going to do this, actually, I'm going to move that down to here. Do some checks here. So what we're checking for here now is if this value here, first of all, is equal to particles plus particle size times max particles. And it needs to be equal to the... Oh, hang on, no, because it's going to be plus... times max particles plus 1. No, times max particles, that's correct, because it starts at 0, so yeah, okay. So we compare it to that. If it's not equal, fetch loop done for it. Can two particles hit the same char? Yeah, they can. That's kind of one of the requirements for us, really. So fetch loop done. It's just going to be here. If it is the same, then I also need to check this value here. So I need to load this value. And I need to compare that with this value. If it's not equal, fetch loop done. Otherwise, we need to jump to end. No, we don't need to jump to end. Sorry, we need to reset these values. So these values are reset here. So I'm just going to copy that from here and paste that here. Right, there we go. And that should reset it. So hopefully now this should not break, which it's not doing. Cool. And that's not actually too bad, considering there's 64 dots on the screen now. I mean, it is taking quite a bit, but I think with a bit of optimization, that could work out all right. And I even think 64 is maybe a little bit too many for what I need. Okay. So let's add the clear routine in, which, by the way, I wasn't calling, so I'm surprised that was even working. So we need to call this here. Okay. So let's see if we can reduce this. So this is kind of roughly the bottom of the screen anyway. It'd be good if we can reduce this to up here somewhere, because I'd like to be able to fit a sprite multiplexer into this as well. So the thing with the sprite multiplexer is it's going to need these values to be changed. Sorry, it's going to need new rasters setting up to hit the kind of top of the screen here. So ideally, this needs to not happen. It needs to be less than that. Now, one other thing we can do is we can double buffer the character set. So not the screen, but the character set. So what we could be doing is we could do this over multiple frames. So we could run the particle system at 30 frames a second. insane how easy it is to consume that many cycles. Yeah, it does. It is difficult to do it right. I think what I am going to do is I am going to run the particle system at 30 frames a second. For the purposes of this stream, though, I'm just going to leave it as it is. But I can half the amount of time this takes by doing it over 2 frames. So you would do half of the particles on 1 frame, half of the particles on the next frame, and so on. In fact, you could do that here as well. So you could do a flicker between the two. If I did this, if I do like that, hopefully that will automatically flicker between 2 sets of particles now. Which you're not seeing because it's not clearing them, but you can see now it's taken a lot less time to do, but it is still drawn everything. So that's actually, that might be the method I might do. So I might do that plus double buffer it as well. So what I mean by double buffering it is at the moment we're using a single character set, but you can have 2 character sets that are essentially exactly the same, except for this bit here. And so you can be drawing to 1 character set for the next frame, while leaving the current frame on the screen. And then as soon as you're finished, you just switch the character sets and it will draw. So let's do the clear routine, and then hopefully you'll be able to see that flicker that I've kind of set up here. So the clear should be pretty simple. The clear is basically going to work. Actually, is this the right way to do this? Yes. Okay. No, the way we're going to do this is quite simple. We're going to have another particle fetch that's going to be separate, and this is going to be the clear fetch. And the reason we're going to have this separate is because we don't want to break where this is at any point. We want to leave that where it is, because of the way that the system works. We're not drawing the entire list in one go. We could draw any portion of the list at any point. So in the clear particles, we're going to have a clear fetch, and we are going to set that to 0 here. And then it's pretty simple. What we're going to do is we're going to have the counter, but this time it is going to go through every character here, like so. And then our loop is going to be here, and we're going to decrement this one. And if it's not equal, we'll go back to loop. So nice and simple. Actually, we can optimize this a little bit by doing not equal. Yeah, there we go. This makes that a little bit more efficient. So the only other thing we need to store when we do this is this X value that we create in here, which is used here. That X needs to be stored somewhere. So in both cases here, no, it's actually been changed. So I'm going to transfer that to the accumulator, and I'm going to store that at particle fetch, y, and that is going to be, where was it? This value here. So that's, I need to load y with 4. Which means here I can just decrease y. Save a little cycle. It saves a byte anyway. Cool. That means that when I want to clear these, what I can now do is the clear routine is really, really simple. So we've got this plot pixel. Basically, we're just going to have clear pixel. And clear pixel is going to be super simple because instead of doing any of this crap here, all it's literally going to do is store a value at that location, like so. So it's, I mean, you could argue we could probably find a way to make these work the same. In fact, we can very easily. Let me do that. There we go. If I put that label there, what I can now do is in this loop here. So if I load Y with 04, sorry, load accumulator with particle clear fetch, comma Y, transfer that to the X register. Then I need to do the same jump table stuff here. So I'm just going to copy that. Let's jump self clear mod, let's call it jump. Oh, it's not going to work. It does need to be set because that needs to return to somewhere different. All right, fair enough. This is annoying having to do this, but whatever. I might find a way around this at some point. So this really is just a prototype, really, just to make sure I can do this. And so far, I'm quite pleased with it. I think it's going to work. So. Okay, so we need to use clear pixel value in here. Clear pixel value in here. MSB. This needs to be jump self clear mod. Don't need these values here. All I need to store is 0. So all I need to do is clear that line. I don't care about turning an individual pixel off or anything. Just clear that line, because if there is more than one pixel on there, it will clear both of them, and then the next time it comes in, it will already be cleared. So self-clear mod, yeah. Jump clear return. Okay. That should clear everything. The only thing I do need to do is make sure that where's it? I do need to do this bit as well. So before I actually grab the particle to clear it, I need to grab the screen location and put 0 in it. So, right, cool. So I think that is pretty much everything I need to do now. So this is probably going to flicker between the two. Clear pixel. Which it's not doing actually. It's not flickering between the two. And it's also taking a lot more space up now. Let me just return from this function here. Just want to see how much the clear is taking up. Maybe the clear is taking too much. Yeah, the clear is taking quite a lot actually. I don't like that. It might actually be quicker to just clear. How many bytes would that be? 64 times 8. So yeah, that's still 512. So it's a lot to clear. Okay. And it doesn't look like it's actually clearing. That needs to be particle clear fetch as well. Okay, so we're getting a bit of flickering here, but it's not what I was after. Okay. Think about how best to manage this. Actually, what we can do. No, maybe not. Let's catch up with the chat a little bit. Okay, I'm not missing anything. All right, good. Okay, what I'm going to do is just as a temporary measure, I'm just going to clear the particles brute force way, which is going to be a bit slow, but hopefully, I know because we're going to. No, we kind of do need to do it this way. Oh, I know what's going on. We're not actually implementing the fetch at all, so we still need to do. Oh, god damn it! This is actually going to be a slow routine, so this definitely needs splitting over two. Because we need to do this basically at the end of the fetch here. So that would be clear fetch. So what I'm going to try and do next, I think, is find ways to speed up these loops as much as possible. All right, there we go. So it is actually clearing them. You can see now it's flickering between the two values. But the clear is still taking a lot of time, so that's problematic. It is flickering between the two, which is good. Hopefully it should be. Everything seems to be in pairs of two. I'm worried now that that's not actually doing its job properly. Let me turn the clear off and see if that's let's do. We might need to find a better way to do the clear, because that seems to be pretty efficient. Let's see what happens if I start reducing things. So like if I reduce the maximum number of particles to 32, particle char count to 32. How does that actually look? Okay, that doesn't seem to have affected that too much, but let's try the clear as well. So what's bothering me here is when I put the clear on, it seems to be doing this strange kind of pairing up of characters on here. So let me just keep 32 on. Let's look again at just drawing on its own. Gee, that looks fine. Lost a lot of shillings today. Let me do another raffle. You had a map earlier. Are the particles eventually going to appear over that? No, so quite the opposite. So the reason the map was on there was because I don't want the particles to appear over the map. I want them to not be drawn at all if the map is in that position. So I'm going for speed. So I'm trying to avoid blending any characters together, which this should do. So you can see there, it's not drawing them at all when it hits the map. You can see actually it's not that bad in terms of speed, but it does need some optimizing. So depending on how many are visible, then there'll be more. But the idea is this is just something to fill out the negative space a little bit. So the particles may bounce off the sides as well, so they may act like proper physics particles and bounce off the sides. But for now, this is Rainbow Islands. On a ridge one 10,000. Well done. Okay, I'm going to start by trying to optimize the draw routine. Let's try and get this as small as possible. So we are grabbing values from, right, so this first thing here is grabbing the particle entry, the screen lookup. I don't see a faster way of doing this. I think this is probably about as fast as it's going to get. There's no difference between loading a value or incrementing just a byte saved. So I don't think that's going to change. This bit here is doing the, that's actually checking to see if we need to actually draw the particle or not. Then this bit is grabbing the value of on screen, which we have to do. So I don't think that's going to be any quicker. Okay, so this bit here maybe could be a bit quicker. So this is loading the next particle char into the X register. And incrementing it here. Okay, so the increment I think that might be 6 cycles as well, actually. Increment is 6. Whereas an increase and store would also be 6 as well. So increase is 2, and a store X is actually store X is 3 for 0 page, but then again, increment for 0 page is 5. So really, it doesn't matter if we do increment or using INC, or whether we do an INX here and store. It really doesn't matter. They're both going to take the same amount of time. Is there any advantage to using one over the other? Maybe not, I don't think. So the clear carry bit here, can we get rid of this? That's interesting to think about. So there is nothing in here. There's no comparison at this point. The first comparison is here. And it's absorbed. If the carry is set, it's immediately absorbed by this line. Same here. There's some comparisons done here. So these comparisons are probably problematic because these are potentially gonna this is potentially gonna set the carry flag. So I think we do need that clear carry bit in here. Okay. And when was it? This one here. Okay, so one thing we do have, we load the next particle chart, we increment it, and then we add this value to it. So maybe we can get away with not doing this if we start this value at the right position. So that would be 256 minus max. Particle char count. There we go. Then that way the value starts at that value, so we don't need to do that. Char selected. Okay. But we will still need to do a subtraction here. Unless, actually, no, we don't. So we can be clever here as well. So the char index was going from 0 to the particle char limit. Compare here. We subtract here, which we don't need to do as well, so we can get rid of that. So that's actually a few bytes saved. And also that means the accumulator is the right value at this point here. Because in both cases, the accumulator is correct, so we don't need to do that. Which means all we need to do here, really, is minus this value. Oops. Done. Because now the X register, oh, I don't know why that is. Don't know why that is there. Transfer accumulator. Oh, okay, yeah, that's totally fine. Okay, so that should give us the same result, but in less lines. I mean, it doesn't look like less because the map is there. Let me put the map, turn the map off. So we saved a couple of cycles, and now you can see it's kind of, before it was off the bottom, and now it's not. Now it's kind of just about showing here, which is pretty good. Because we've saved 2 cycles there, 2 cycles there. So that's 4 cycles or 4 or 6 per loop, depending on which route it takes through. So between 4 and 6 per loop. So times that by the number of particles, and we've got 32 particles. That's going to be a couple of lines. That's like 2 or 3 raster lines of saved there. Okay, so is there anywhere else we can save? So the other place that was problematic is this bit here. This is quite slow because we're doing a lot of addition and subtraction here. So for instance, if I take this out and I don't do any of these, I don't actually fetch the next particle. We'll only see one particle on the screen, but it will try and draw it many times. And look at the difference. It's saved loads of lines because we're not advancing to the next particle. So maybe there's a way to do this as well. So let's have a look. Okay, so, well, one thing we can definitely do is we can use branching carry clear here to increment to this position here. So branching carry clear is, if it takes this branch, it's going to take 3 cycles to do, whereas this bit here is going to take quite a lot more. It's 2, 4, 8 cycles. So that saves us 5 cycles at a time. So this is 8 cycles, which means we can reduce that to 5 cycles like that. So now we're saving some space there, saving some cycles. We can't really change this. This needs to stay the same. And these comparisons, I think we still need to have. But we've saved about 5 cycles on average per frame there as well. So let's run that. Okay, we've got a problem there now. Why have we got a problem? Let's just undo, make sure that that's not. Should carry clear. Yeah, let's just make sure that that's not a bug. It seems fine. Let's run it a few times. Okay. So why was that break? So let's just put the branching carry clear in. You can see already it's saving a little bit of cycles at the bottom. This is shrinking a little bit. This is nice. So I don't know why that suddenly broke when I did that, but apparently it did. No, it's fine. Oh no, there we go. It broke again. Because here we're comparing it. So actually, we're probably better off leaving that in. And this is 8 cycles, but it means we don't have to load again. Load again there. Um, the saving really is from this bit anyway. So can we change the comparison? This is the other thing. If we can find a way to make that comparison work better, then that would be good. Because again, if we run this now, so we're definitely saving because we're starting to free up some room down here. So if we take them comparisons out, so it's just going to print the same particle over and over again now. It's actually taken longer because now it's refreshing every time here. So just get rid of that as well. So yeah, you can see it's not. Oh, that went all pear-shaped. Something like that. Pear-shaped. Oh, because we're adding to the particles now, and we're never actually resetting, so it's going out of bounds. Okay, so we do need that comparison in. We can't take that out without breaking something. So, question is, where do we do it? Hey, Dave Velociraptor, welcome to the stream. Okay, I'll tell you what I'm going to do. I'm going to take a quick break while I have a think about things. I think this is looking promising now. I think with a bit of double buffering and flickering between 2 sets of particles, I think this can work. I think this can work at 30 frames a second with a bit of tweaking here and there. I mean, it's not going to be the hundreds of particles that I was hoping for. It's kind of been a bit optimistic when I thought I'd be able to do that anyway. So, all right, I'll be back in 5 minutes, guys. Be right back. I'm back. I think the SID has just finished anyway, so. Oh, maybe not. Oh, no, it's ended. There you go. Okay, so I'm quite pleased with the draw routine. I don't see a faster way of doing this just yet without unrolling this loop. I mean, I could unroll this completely, but because I'm using this kind of divider here, I mean, if I divide it by 4, you'll see it uses even less space. But 4 is probably going to flicker a bit too much, so I think 2 is probably fine. The trick now is getting the clear routine to work. So let's think about the clear routine again. Let's just call this clear particles 2. Let's just make a fresh one and try a different method. So what am I trying to achieve with the clear particles? So first thing I need to do is I need to remove the characters that are on the screen. And that is all of these locations that it points to in this list here, basically. So I can probably do that with an unrolled loop, actually. So let's just copy that just for simplicity, and go ahead and use this to clear values. So because it's an unrolled loop, I don't need to use the Y, the indirect indexed thing here. I can just use particles plus I times particle size plus 0, and store that at screen fetch plus 0. Like so. And then if I keep Y 0 outside of that loop, and if I use X here and set accumulator to 0 here, then I can just do that. So that's going to clear all the characters on the screen. It's not going to clear the contents, but it's going to clear the characters. So I'm not sure what we'll see when we do this now. Let me just re-enable that here. We see a mess is what we see. Okay, something has gone horribly wrong here. Articles, screen address. Yeah, let's just do that with one, just see what happens here. So we're getting this weird flicker on here, so there's definitely something wrong here. Okay, this should be grabbing the right values. Just for testing, just going to make sure that there's nothing weird going on. So it's fine until I actually run this loop. So what is this doing? This is grabbing the value at this location. This location should be, I'm going to put this in brackets here just in case, because I have noticed in the past some weird stuff happens with, no, okay. Sometimes some weird stuff happens with that. Screen fetch. So this is the screen location. Y shouldn't have changed. Accumulator won't have changed. Okay, why is that different then? That's odd. Okay, where's our particles? Our particles are at 4,000. So let's put a breakpoint in here. Just go and have a look what's going on in the code here, just to make sure that those values are correct. So, yeah, we've got 4,000, 4001, 4008, 4009, and it's storing them at 6 and 7 every time, which is correct. Let's put a breakpoint at this point. Oh, not that one, there we go. And go and have a look at what's in 6 and 7. So 6 and 7 is here, 3662. So this should be fine. This should not be grabbing the wrong values. But for some reason it is doing. It seems to be causing a crash here for some reason. Okay. F9, it stores at 6 and 7. Oh. So why would it be failing to do that? What's going on? What's going wrong at this point? Oh, see, it's not. Okay. It's failing because the last thing we need to do is set the particle char in here. And that needs to be this value here. So that might help with the. Okay, so we're seeing some oddities, and that's because it's trying to use the same characters again, but there's already some stuff in them, so we need to make sure those clear. So first of all, I'm going to do a very, very simple brute force clear. It's going to be very inefficient, but I'm just going to do it just to make sure that the routine will work even even if it's very inefficient at this point. So so we'll store that at, I'm just wondering, could we maybe speed the clear up by storing the actual address that it grabs from? No, maybe not actually. That looks rude. Use parentheses. The reason why I use square parentheses here is because if you use square parentheses, it has the same effect as using these, but you don't end up accidentally invoking a different addressing mode, which you can quite easily do. So it's a good practice to use square brackets instead of normal parentheses in this instance. Because, for instance, that means something different to that. One is a different addressing mode. One is a calculated address, a normal indexing mode. So okay, so I'm just gonna very, very quickly do this here. So this is just going to be should, I mean, it's going to take a lot of memory to do. Oh, actually, that's relatively efficient. So you can see the flicker between the two, which is kind of what I was expecting. Actually, that's not as slow as I was thinking it was going to be. That's actually not bad. Now, I don't mind the particles flickering because the whole point is that they're not they're non-interactive. They don't serve any purpose other than to decorate. So I'm just trying to start my because I want to see how it looks on a real machine without the frame sync issues. Well, that's not coming through though. Maybe it didn't get the signal from the machine. So the only thing I need to do here is grab the make file. So I'm going to go and grab it from the game. So we've got one in the game. That's it. Okay, that's not going to work. That's annoying. Okay, so this needs to be start. Is okay. That's set. Why is it not appearing on that? For some reason. For some reason, my oh, because I've not got it plugged in over here. Maybe. Can see. There we go. Right. Okay. So now, if I just run this on here, hopefully it should appear on here. Failed to connect. Oh, I've not plugged my Ethernet in. God damn it. We'll get there. Let's try again. Yeah, and you can barely see. In fact, it's almost impossible to tell that they're flickering, which is good. That's what I wanted. So, in theory, what I should be able to do now is improve the performance even further um, by maybe reduce. So I can keep reducing this now until the flicker is acceptable. So in here, if I reduce that down a little bit more, so it's flickering like crazy on here, but on here, hopefully, I need to turn that one off. The flicker will be fairly constant. And it doesn't look that bad. They do flicker, but they're not as bad. And I'm not using that much time now. Okay, so that's kind of acceptable. So now let's try up in the particle count and the particle char count. Now that's going to have a massive impact on timings, but you can see we're still off the top here, but we've got way more particles now. Right, so first of all, what I'm going to do, I'm going to fill the screen with white because I'm kind of, it's a little bit annoying looking at, let's make that 0. It's kind of hard to see. This is going to make it a little bit easier to see those. Because the screen's so bloody small, it's hard to see individual pixels on it. Okay, that didn't actually change anything to white. Final countdown. Okay, so that's kind of crazy flickery now, but we've now got 64 particles being rendered. And I still think the clear routine can be massively optimized because at the moment we're just brute forcing a clear on the particle list. And it doesn't look that bad. They are flickering, but it's a steady flicker. They don't look bad at all. And yet I've got 64 particles on there now that I can individually mess around with. So that's pretty good. Anyone else having trouble seeing the particles? Yeah, I mean, they're easy to, they're a lot easier to see on here than on the little monitor down here. The problem is with on here is because of the frame sync issues. Even on my monitor, the flickering is very what's the word? It's the kind of, it's not a stable flicker. It's not the same, and it's because this is updating at 50 frames a second, whereas the monitor is updating at 144. The stream is updating at probably 60 or something. So it's going to look weird. But if you look on this screen here, which unfortunately you can't see, then you can see that the flicker's a lot less. Even if I was to point the camera at it, you would still get the same effect that you're getting here anyway. But that flicker is set, especially if they're moving around. So my next job now is to try and reduce this time a little bit. So this is 64 particles. Yeah, if you look at this screen, which you can't see, like I said, even if I point the camera at it, you're not going to be able to, you're not going to get the same effect. You're still going to get the strange flicker. Yeah, see, you can see there that unfortunately, the stream is making the flicker more pronounced, which is not the case when I look at it myself. So, in fact, if I show you, so if I put it down to 2 here, the flicker is almost imperceptible. You can definitely see it on stream here, and you can not see it at all on this screen. But if I showed you, you would probably still see a flicker. Actually, you don't. Interesting. What are you listening, Mr. D? Oh, okay. Thank you. My God, they do try, don't they? Banhammer. So actually, yeah, they look pretty stable. You can see there they look pretty stable. and that's the same as what we're seeing on here. So you can see they flicker like crazy on the emulator, but you can see on the main screen here they're absolutely fine. But you can see they're stable. They're stable up there in the top. That's interesting that the camera doesn't pick up. Well, I guess because it looks stable on there, the camera's just showing what. That's interesting. I'd say it's interesting how that works. Oh, what have you done, Andy? You've banned the wrong people. You've accidentally banned Mr. G. What is going on? I don't know how to unban. Sorry, Mr. G. I think Andy's just kind of gone on a little banhammer mission. I think you've accidentally got caught up in it there. I don't know how to unban him. I'll let Andy figure that out. Yeah, Andy's figuring it out. Apologies, dude. And there you go. Just as an apology thing, if you accidentally get banned, you get an extra 10,000. At least Turrican didn't win. Yeah, it's supposed to be Stepz who gets accidentally banned. So I'm quite pleased with this. This is looking pretty good. Like I say, this is with a 2-frame update, and it looks absolutely solid on a real machine. I'm happy for them to flicker, so I'm going to drop it down to 4, which is going to give us a lot more raster time free. Most of this raster time now is actually being taken up by the clear. If I get rid of the clear, you'll see just how much we're wasting on clearing. So this is here. Let me put the debug borders on. Kind of need them to see. Scroll to debug borders. As you can see, it's just using this amount here. Whereas if I turn the clear on, it's going crazy and adding at least maybe 2 times the amount that it took to draw them. Oh my god, are they all? It's still coming in. Are we still getting spammers? If we're still getting spammers, I can just change it to sub-only chat for a short while. Should stop them coming in. I don't understand the mentality behind it at all. There you go. Gunstar's done it. Yeah, just for 10 minutes or so, Gunstar. Thank you. So apologies if you can't chat at the moment. It's just a temporary measure while we deal with the spammers. I think they've stopped actually, but who banned me? Okay, you might as well turn it back off. I think Gunstar. I think it's stopped now. Thanks. Okay, cool. Yeah, at least it's not the massive follow train that I got last time. That was horrific. Thanks for unbanning me. It's so it just makes no sense. But the last time was the just about to make use of my gifts of the Russian bots that happened like last year was just ridiculous. when they spammed probably about 500 follows. It was ridiculous. All right, this is looking pretty good. I mean, in terms of how it's viewed on stream, it's not great, but I'm happy with how it appears on there. Let's see if we can optimize the clear routine a little bit. So at the moment, we're using quite a lot of memory to do this, but I'm not too fussed because the game that I'm going to be doing that's going to make use of this is going to be done using Gmod anyway. So and it isn't a complicated game. It's a flick screen game, so it's not going to be there's not going to be huge amounts of kind of unrolled loops for scrolling or anything. So using some unrolled loops for this is going to be fine. I'll probably do an unrolled loop for the multiplexer as well, because I want the multiplexer to be pretty solid. So let's have a think about this. So at the moment we're just blanket going in and clearing all those particles. And by making the particle char count lower, so if I make it 32, but with a higher amount of particles, what happens? Okay, I'm gonna line this up. Okay, so I'm lining this up with the red line on the 0 page there. 64. So yeah, it adds a few extra lines. So maybe reducing the char count down. So let's see how low I can get the char count before it starts looking a bit weird. So let's do 24. Draw particles 4. Let's try that. Okay, now let's try that on this machine. Just want to see how it looks. Looks exactly the same. Hasn't made any difference to the view on there. Okay, that's pretty neat. So let's do it down to 48. How much better is that? Okay, something weird has gone on there. Let's drop it to 32. Maybe it needs to be a power of 2. And already we're not using any raster time beyond the V blank at the bottom. We've got V blank 3 at the top, which gives us time to do multiplex up here maybe, or even the sort could probably fit in here. And then you still have enough room to kind of, yeah, to do all the extra things. And that's with 32 particles. Let's see how that looks on the phone. It's all right. Flickers as much as I would expect. I think I prefer 64 though. 64 is a nice number of particles to have. So if I can figure a way out of reducing that a little bit, that'd be really good. So let's have a look at the clear. So I'm going to get rid of this clear particle routine because this was very inefficient. In fact, let me just try turning it on again and see if it still works. No, so it had issues anyway, so let's just get rid of that. I don't think that's ideal. It also means we don't need this bit here, so that makes that a little bit simpler. We use one less 0 page as well. Actually, 2 bytes less than 0 page. So can we make this any more efficient? Probably not. And this is going to be about as fast as I can get it. This is clearing the values on the screen. This is clearing the now. The thing is we're clearing way more than we need to here. We're only drawing 64 particles, so essentially there's only 64 values that we need to clear, and what we're actually clearing is 512 values. The problem is in order to know whether or not we need to clear them, we need to do some additional trickery, because we need this calculated value here to be stored somewhere, and I don't think that is going to be efficient enough. Yeah, it's not going to be a good way of doing it, I don't think. let's give it a try though. Let's try using some of these extra values. I know we're going to use these for dx/dy, but let's just try. Oh no, see, it's still not going to work though. Still not going to work. Yeah, it's not going to work. I don't think. I think this is acceptable, and even like reducing this down to 16 is not going to have a huge impact on it. The flickering is going to increase as we decrease this value. The flickering is going to increase if we increase that value. So decreasing this is going to increase the flicker. Increasing this is going to increase the flicker. So this is going to be quite an oh no, see it broke there. Why is it broken? I think that might be due to page boundaries or something. 64 seems to be fine. Yeah, I think this is acceptable. And as I say, I can double buffer this as well, so this would probably save even more. Oh, thanks for the follow, Greg Twee. I missed that as well. That was an hour ago. I might have been on a no, I wasn't on a break. I think I just missed it. I'm not hearing alerts as much as I should do. I don't think. Keep missing them. My guess is people create the bots to see if they can create a lot of attention and response from them. The weirdest bots I've seen are ones that go around niche forums making almost relevant posts copied from other forums. Yeah, it is kind of funny. I don't understand why they'll do it. I mean, it's not exactly a huge achievement, but they seem to thrive on it. Yeah, I think that's fine. So that gives me 64 particles. It only uses 16 characters. In fact, we can see this happening. If I run it in the debugger, you should be able to see it happening in a much nicer way. Let's get rid of that one. Oh, what's gone on here now? If I ended up, God, this is the problem with the debugger. It does have its issues. You've got to kind of leave it alone, let it load up. Might have banned the alerts by mistake. Let me test. Let me just replay the follow. Oh no, I just missed it. It's just me being slow. So so if we have a look in, God, where is it? Whichever one it is that has the, there we go. So you can see them being redrawn each frame here. You can see them flickering on and off. But I'm fairly happy with that. I think that gives me enough to know that I can do what I need to do with these particles. Now, obviously, the next step is moving these around. So let's just do a simple update on these. So let me just do, let me just do some tests on this. So let's do update particles. And for now, I'm just going to do really simple thing here. I'm just going to in fact, they could even be done in the clear particles. But I'll do it separate for now. But it could be done as part of the clear particle routine. In fact, the update needs to happen after the clear. Right, so we're just going to do a simple routine. I'm not going to do anything special. I'm not going to advance them through the screen anywhere. I'm going to leave that for the real stuff. I just want them to move, just so even if they just flicker around in the same area. So I'm going to load particle. Let's grab. So it's these two here. So it's +2 and +3. I'm going to mess with. So actually here I should just be able to do. So if I shift it to the left, no, load accumulator, shift it to the left, add 0, store it. That's going to actually shift the particle in an 8-pixel loop. So they're actually moving incredibly quick. That's the problem. Also, because they're updating every other frame, you're not really seeing the benefit from that. You're not really seeing them move. I would have to get rid of this here in order for that to work properly. Oh, and that should be max particles -1. Oh, no, it fails massively when I do that. Okay. Now, is that because of the update? It just because of the update. Let's just get that out a second. No, it's really doesn't like doing all of the particles at once. Let's do divided by 2 again. Oh, pressed the wrong button. Oh, what have I done here? I've completely broken it now. Should be fine in terms of memory. Just come out of forum spam bot that was nearly impossible to tell from an idiot. Could you make? Well, I mean, people have been doing that on Twitter for a while now, haven't they? It's all over the place. Skynet does already exist, by the way. It's just not what you think it is. So there's a Chinese company that does facial recognition for the government, and their system is called Skynet. And somebody, I was watching an interview where somebody asked them about the irony of calling it Skynet, and they were like, "No, ours is a good Skynet. Ours is good. It's not bad. It's not an evil thing." It's like, well, okay, but you're using it for facial recognition for the Chinese government to kind of to do crazy things. Like they use it to map your social circles, so they can map your face to other faces as well. Like, oh, this person meets with this person a lot. They can map you to your car, to the place you work, and things like that. So they have kind of crazy information on everybody in China. It's very scary. Maybe the one in Terminator was the good Skynet after all. Well, I mean, it did try and blow the planet. Well, it did blow the planet up. Well, blow parts of it up anyway. I'm a bit bothered why this is. Maybe if I need to do -1 there as well. No, it really doesn't like that at all. Okay. Okay. Apparently, divide by 4 is what I need to do there for some reason. I couldn't tell you why. And I learned from yeah, Terminator did run 6502. Yeah. Shit, which is kind of crazy. So the Terminator could blow you to pieces with a Uzi 9mm, but he couldn't do division without wasting a lot of time. So that's how you defeat Terminator. You just give him a long division problem. Not that he'd stop to solve it; it'd just blow you away, wouldn't it? But maybe the Terminator 2 metal one, was it T1000 or whatever it was? Maybe that run on 68,000. So who knows? But yeah, it was definitely 6502. So I found really funny when I was looking at. I think Terminator had a mass coprocessor. I wonder if anybody's worked. Oh, I think somebody did figure out what that code was from as well. I think it was from an old Apple. I think it was from like an Apple II or something like that. I can't remember. Was it that? I think it was that. Somebody had figured out where that code had actually come from. Yeah, Apple II stuff. Yeah, it's kind of funny. All right, I'm not entirely sure why changing the particle count stops me from running like all the particles at once, but it seems to have some issues with that. But it seems like, I mean, the difference between this, which again, like I say, on my machine here is stable, just a stable flicker, and this, which is using less characters, it just seems to be the number of raster lines, because the flicker is just as stable, but it's using less lines, so that's good. I think 32 is a decent, 64 is a decent amount of particles to have. Yeah, I'm quite pleased with that. I'm not going to do much more to that now, I think. There was analysis of it on pagetable.org. Yeah, it doesn't surprise me. It's Terminator colorblind. He did seem to see in monochrome with like a red tint, didn't he? Oh. All right, I think I'm going to call it there, guys. I'm not going to play anything extra tonight. I'm feeling a bit tired, so I'm gonna leave it there. I was asleep just before the stream, actually. I'll share this code after the stream as well. I'm not sure it's going to be that useful to people, but you can use it as a reference if you do need to. I'm going to probably do some more tests at some point and try and optimize it a little bit more. I will do it in this project, and I will update it in this project as well. Yeah, Bender from Future. Yeah, Bender had the 6502 as well, didn't he? Yeah, I remember now. It's really funny. They had there's loads of references actually to kind of retro computing as well. Yeah, no problem. All right, cool. Let's go and find someone to raid then. So remember on Saturday as well, we're gonna have okay, I'll run it again. So you're not gonna see, it's gonna look very, very flickery on the screen because of the way it works, but basically this is rendering half of the particles on one frame, half on the other frame. Actually, it's doing it over 4 frames, which allows us to have 64. But on the real machine, it's just it's a very steady flicker. So, but it's exactly what I want. It's about the right number that I want. So, yeah. So Saturday is going to be the giveaway stream. We're going to continue with the game as normal, but I'll open the entries at 9:30. The ticket's going to be 2,500 this time, just up slightly from the last time. So you're going to need, and you're going to be able to buy 3 tickets. So you need 7,500 channel points in order to buy all the tickets. Same rules apply. You buy 3 tickets, and then at midnight the entries close. We'll run the giveaway bot thing. No, I can see that. Base liquor. Yeah, can see you. Yeah, so we'll run the giveaway at midnight again. Same rules apply. You have to reply within 5 minutes to claim your prize. If you don't, unfortunately, it gets rolled over. So just make sure you're paying attention at midnight. I'll give some kind of countdowns to when it's going to happen. So I'll say like in an hour, on the hour, in an hour. And you can win. Oh, actually, one thing I did get, should show you. we've got the Competition Pro joystick to go with it as well. So it's a proper Competition Pro. It's not the USB one. It is the Leaf one. It's not the clicky one, so you can't hear it click, unfortunately. It is just a Leaf one, but they're still very good joysticks. So it's perfect to go along with it. So it will come with a joystick. It will come with everything you need basically to plug it all in and get it running. So yeah, I'll be giving that away on Saturday. So fingers crossed for everybody. And then I don't know what the next giveaway is going to be, so we'll have a look at it after that. Basic and no, this is 6502 assembly, but in a modern kind of IDE and modern assembler. Yeah, Saturday. That's going to be this Saturday. So it's going to start at tickets are going to open at 9:30 as soon as the stream starts, and they'll stay open for 2.5 hours until midnight. So right, let's have a look. Who can we raid? Hungary's on, Chinese Hawk is on. Okay, let's see who's playing the most interesting game. So that looks like a NES game, I think. Hungary's playing. Actually, that kind of looks like Ghosts and Goblins. It is Ghosts and Goblins. All right, she wins. Before I've even looked at Chinese Hawk. Okay, let's go and raid Hungary. All right, cool. Thanks, guys. I shall see you all on Saturday. Take care and see you then. Cheerio. Oh, actually, I need to click the raid. I need to start the raid. All right. Almost ready to go. Right, and we're off. All right, see you Saturday, guys.